So we talked earlier about the stages in a stream, and I mentioned splitterators. Now we're going to talk more about what a splitterator actually is, and you get a chance to understand what a splitterator is, starting with what is the name, and it's a portmanteau, which stands for splittable iterator, or splitterator. So Spliterator was a new type of iterator that was added in Java 8 and beyond, and refined a tad as it went along. And basically, it combines two concepts. One is the concept of an iterator, which can be used to traverse the elements of a source. So assuming we have, say, a list of strings, which has a famous quote from Hamlet, where Polonius, the tiresome, verbose, meddlesome counselor to the king, is giving his son Laertes some sage advice about how to behave when he goes to school in France. He gives a bunch of great quotes, which he doesn't actually live up to in his own life, but be that as it may. So we're going to use that as the list of strings. And you take this list of strings, which is a collection, and then you go ahead and use the splitterator method. Remember, every collection has a splitterator method. And that's going to split up that collection, that list, into individual chunks, one per element. So this, above, all, to thine own self be true. Sounded like Captain Kirk from Star Trek. That's what this will split up into. And then you can call the tryAdvance method on the splitterator. So splitterator is a factor method on a collection. You get back a splitterator. And then you can call the tryAdvance method on it. And that essentially combines the behavior of hasNext and next on an iterator. If you remember Java iterators, iterators have a hasNext method that returns true if there's another element in the iterator, and then next gives you back that element. So tryAdvance does both things. It returns true if you got something, and it also has the effect of doing something. And the doing that it does is it is given a method reference, or it's given a consumer, and we'll take a look and see what this does. So this is how tryAdvance works. You can see tryAdvance is passed a consumer, and if there are no more elements in whatever you're iterating over, like if you're iterating through this list of strings and you've exhausted them all and emitted all the strings, then no more elements remain, so you return false, nothing happens. Otherwise, you accept the next element in the collection or the source that you're iterating over, or splitterating over, and you accept it into the consumer using the accept method, which is basically a kind of a pass by reference style way of getting the value. And then you return true, saying, we got one, try again, keep going. So in this case, we're going to print out the value of each of the strings in the quote using the print method, which is passed in as system.out : print. So it's a method reference. So that can play the role of a consumer. The other thing you can do with a splitterator is you can split it. So you can partition things up into chunks, groups of chunks, ultimately culminating with a single atomic chunk when it's split. So let's take a look at an example here. So we're going to do two splitterators. The first, we're going to say quote.splitterator. So that's going to get us essentially a splitterator to the second half of the quote. You'll see why that is in a second. And then we're going to say, well, actually, it gives us back a splitterator to the whole thing. And then we're going to say second half.trySplit. And what that will do is that will return a new splitterator that's going to cover the first half of the content. So this, above, all, to, or to thine, depending on how you want to split this. And then what will happen is the trySplit method will modify the second half, which is this first splitterator, to be whatever's left over, like own, self, be true, new line. So now we've got ourselves two splitterators, one that covers the first half, one that covers the second half. And then we can go ahead and do something with it. So here's what trySplit does. If the input is less than or equal to some minimum size, return null, which says we're finished splitting. We have an atomic size element at this point. Otherwise, split the input up into two chunks. So we take the original input. I should have put the candy bar here. And now we split it into two chunks. And the right-hand chunk is updated to skip over the left-hand side. And then we return a splitterator for the left chunk. So you get a new splitterator that covers the left-hand side, and the right-hand side is updated to only include the right-hand side of this. So now we got the two chunks separated out. So now that we've got the first half and the second half splitterator, we can then use one of the other methods defined in a splitterator, which is for each remaining. And for each remaining takes method references and does everything there on the half that that splitterator is working upon. So first half for each remaining, we'll go ahead and print out this above all to thine, and then the second half will print out own self be true new line. So that's how the splitting part of a splitterator works. Now, you might be asking yourself at this point, why the heck would I do this stuff? Well, for sequential streams, that's a very good question. You probably wouldn't. But for parallel streams, you would. And, or not you, the Java Streams framework does this for parallel streams. Because what it's doing is it is recursively splitting the original source of input up into smaller and smaller pieces until they reach an atomic size chunk. And then those atomic size chunks are mapped into the underlying tasks in the common fork join pool, and then they are processed in parallel on all the different intermediate operations, culminating with the terminal operation, which could join them back together again with the results of doing the intermediate operation process. So that's basically how Spliterator works. Since we're focusing here on sequential streams, we're only going to discuss iterators and the iterator behavior now, and then we'll come back later and talk about the splitting part when we get into parallel streams. So that's the end of our discussion of Splitterators as a concept.